All right, we're going to kick things off. So if you're still coming in, if you could just try and be quiet. So we have Micha here to talk about continuous delivery with Kubernetes.
Thank you, John. So again, this is not about compliance. So Berlin. Thanks everybody for coming to see my talk. So yeah, it's entitled Continuous Delivery, Kubernetes and You. This talk is also known as Building and Delivering Apps in a Cloud-Native World. So I'm going to talk real quickly about how the current paradigm in building and deploying apps is sort of lacking in what we need, and that we need a better way and new best practices to do continuous delivery and build automation in this cloud-native world. So in prepping this talk, I came to the conclusion that it's best told in two parts. So I want to quickly go through some microservices issues and talk about that, and then slowly go into building and delivering apps on top of, in this case, Kubernetes, because we are at CoreOS Fest. So microservices. The thing that I find curious is that like microservices wasn't really a thing before 2014, at least according to this Google Trend slide. So yeah, a lot of talk about microservices more recently, and the question is why now? Why is this interesting? Back in the day, of course, we had a different word, service-oriented architecture. Loosely coupled services been around here for quite some time. So quick recap on microservices. I think we all know the Unix philosophy. So building small, sharp tools. We write programs that do one thing and do them very well. They should work together. They should handle text streams because that's a universal interface. And if you think about microservices, they're actually not that dissimilar, right? We write small, sharp services. They do one thing. They have one single responsibility. Do that well. They should work together. And in terms of communication, like HTTP is a nice universal interface. Of course, there's others as well, but so that's sort of the way I'd like to think about microservices. So what are some of the drivers, at least sort of business drivers, in order to adopt microservices, right? One, I believe, is the need for speed. We went from weekly to sort of daily to hourly releases, and the reason for this is that we want to quickly iterate on our product. We not only want a rapid feedback cycle from our customers, but we also want to be able to quickly adapt to the ever-changing environment. And so fast iteration and quick feedback cycles sort of give us business agility, and that means that we can remain competitive, which is good. The other thing is around communication. I think if we grow a team beyond a certain team size, start making sense to split up the team into smaller groups, split up the responsibilities, and hence work on different services. There's a nice blog post by Phil Casado from SoundCloud, how he describes from a non-technical perspective how they went with and why they went with microservices at SoundCloud. Microservices means micro challenges. We're running more than one process. We definitely have more than one code base because we split up our team. More than one configuration. So you might be running a development environment that needs a specific configuration. Might be a production. Similar in terms of the infrastructure that the processes are running on. More than one environment. So there's more of everything. Which is a challenge. So I created this sort of treasure map that describes what the process for teams is sort of moving towards microservices, and what sort of the thought process is. So we start off with sharing a code base is hard, and as such, microservices are the answer. We're going to split that up into different code bases. But now we have some new problems, right? The code base gets out of sync. We have multiple code bases. How do we make sure all these code bases work together? So we come up with, API contracts. We need to define how these services work together. But as such, we also need to enforce these contracts and test all the API contracts. But how do we do that? So we need to spin up these services, make sure to communicate in the right way, again, ranging in all these different environments and with different configuration and management, so we need some orchestration around that. And obviously, we want dev prod parity. We want to make sure that everything that runs on our production environment closely is replicated on maybe our developer machine. So yeah, big challenges with moving to microservices. Some of the key questions are: how do we run them? How do we test them? How do we ship them? And preferably, how do we automate all these things, right? Love that guy. End of part 1. So now time for a small intermezzo. What about Docker? Wasn't Docker supposed to solve all these challenges, all these issues? Well, yes and no. And I think if we sort of look closely at their own metaphor, the shipyard metaphor, I think Docker solved a lot of different things, right, and did that quite well. So, taking the real life as an example, we've got the format of the container, the specification, the locks and the size, et cetera, et cetera. So we got that. We got the container format. But if you look closely at the shipyard, there's actually a lot of different tools and things going around here, right? For instance, there's this transshipment crane that moves the container from the boat to the docks. There's a boat, which you could, that could be Kubernetes, for instance. There's even a truck somewhere. And more importantly, you can't see him, but there's actually a guy on the floor making everything run smooth. So we just don't really have the tools and processes yet for this Docker world to make this repeatable, secure, reliable, all day, every day. All right. So how do we go about? So we know the underlying questions that drive the adoption of microservice. We understand how Docker fits in to some extent. Let's focus on the question of building and delivering applications in this containerized world. So the key question is, how do we create this stable, repeatable, collaborative, because we're working in teams, build and delivery workflows, all in an automated fashion, right? Without using our hands. So our stack might look like got some sort of infrastructure. Of course, we're running CoreOS on top of that. We might be using a scheduled service, in this case Kubernetes. We've got some logical grouping of our application in Kubernetes slang, pods. We're running containers, Docker, and we've got different apps and services on top of that. So what is the thing that we're trying to achieve? We need to build a container, that's Docker. We need to push it and then deploy it. How hard can this be? So what is some of the tooling that we actually currently have available? So one of the key things is Docker files. And I think we all can agree that testing is a good thing. So Docker files are actually sort of a terrible place to test your services. You might be installing test dependencies inside of your container that you don't need necessarily in production. One way to solve this is maybe create multiple Docker files, one for your image format that you want to use your service, and then have a separate testing Docker file. So you push that to registry, let it build it, but now you've basically shipped before testing it, right? The other thing is sort of build does not equal runtime containers. You want to create containers for multiple purposes, maybe based on the same base image. We want to create multiple containers from one Git source, maybe one for development, maybe another for production. I think we've all seen the multi-gigabyte containers on the internet. I think that's sort of a challenge as well. I do believe we're moving to Alpine for a container format, a base image format, but that, for instance, does not have like a common vulnerabilities and exploitation database. So we're actually now using containers that might have issues. And then the other thing that we probably have seen a lot of times is having one run command and have it, with a bunch of backslashes, execute multiple things just to make it into one layer. So Docker files is not really the best way to get this build process up and running. So what do we need? So we want to programmatically create containers. We want to create them in multiple phases. We might want to throw things away along the way. We might want to add things. So that's sort of the basic premise. We want to split this up into multiple pipelines. The other thing that we want is enforce our API context. Like we just previously talked about, we're building microservices. We need to make sure the thing that I'm dependent on is still working with my code base. So we might have a build pipeline for a backend worker, a separate build pipeline for an authentication API. I need to be able to leverage those containers in my test phase and then subsequently push my own container to registry and then maybe deploy it. So we need to ensure all these services work together. The other key thing, like I sort of said as well, we want to create containers for different purposes. So we might have a base container we might test that, but we want to create a development container that our team can use, our coworkers can use, but a separate container that maybe has JavaScript that's minified, a specific release container that we're going to push to production. So different containers for different purposes. And then the final thing is multi-environment complexity. So we want to be able to fan out our pipelines. In the case of maybe pushing to a development cluster, have a separate container live there that maybe has some debugging information. And we want to create, again, like a production grade container that goes to a separate cluster. So we need some type of fan out functionality. And then the final thing, which I still think is important, we want to let our friends know. This is not a solo business. We need our co-workers to know, who's building what, who's deploying what to which environment. So we need to let our team know. And obviously also have some central point of authority, and don't touch kubectl, in this case, from our laptop. Demo time. So yeah, at Worker we've been thinking a lot about these things because we're building this continuous delivery and automation platform based off containers. So I want to share some of basically share a demo on how we are thinking about these things. And for this, I'm going to mirror my display. Let's see. So we have this app on GitHub. Hope you can all see this. And it has, it's basically a to-do app, and it has different pipelines. As I said, we want to chain pipelines, split up our build and deploy process into multiple phases. This is a dev pipeline. I haven't really talked about this, but in the case of Worker, it comes with a command line interface, which means you can spin up your containers locally on your laptop and get dev prod parity. But that's sort of a side note. We have this initial build pipeline. So this is a Node.js application. At the top, I've specified the node container that I want to use. Here you see steps I need to perform in order to build my initial container. Install packages. So with Worker, we've got two types of steps. One is steps from our registry. So we got a marketplace that has steps contributed by the community. And we have sort of inline scripting steps that you can just sort of have ad hoc scripts. So I'm doing my initial build, building my base container. I have a separate pipeline that goes through the tests, runs our unit tests. After that, I want to both kick off a push to Quay that has my development container, so that's the container my team can use. But I also want to start working on my release container because the tests have passed. I'm able to start rebuilding that container, do some housekeeping, and get that production-ready container up and running. And I finally, of course, want to push that release container to Quay as well. And in this case, we're leveraging this Nginx container. So this is Worker. zoom in? Oh, sure. When I'm back. But now I'm showing worker, so I'll get back to code in a bit. Yeah, so this is worker, and actually this is showcasing the different pipelines that are connected together that we just went through in the worker YAML. So our initial build has passed. My coworker Benno has committed something to GitHub. We're storing our container, and all the other pipelines are going to get triggered. So the way to hook that up via the web interface is you define your pipelines. So these are the counterparts of the worker YAML pipelines, and then we have this visual editor where you can connect these different pipelines together. You can also specify, for instance, if a pipeline should run on a specific branch or not, which is nice for auto deployment, for instance, to staging environments or production, if that's your thing. Right, so we're creating our debug container, has all the dev dependencies inside of it, but we're also creating our production-grade container. You can zoom into sort of what's going on in there. So here you see the different steps that you saw in the worker YAML as well, and it's executing this Docker push thing now. So back to the worker YAML. Yeah, so in case of deploying to Kubernetes, we have two separate pipelines. So I'm using certificates, by the way, for authentication. So I've got this kube initialize pipeline that creates my replication controller, initializes my service. So I only need to do this once, so that's the reason why over here it doesn't get executed automatically. So this is a manual action. And then we have a kube deploy pipeline that actually does a rolling update of our to-do app, which is nice. So we're already pushing this release container. And for the sake of it, I've obviously already created a Kubernetes cluster. Some other nice things that you can do is specify environment variables, so secrets that you might need, or in this case, the Kubernetes master is hard-coded, or some of the certificates, which is quite nice. Right, so we have a release container, and now we can manually deploy this to Kubernetes. Which we'll do a rolling update of our service. Just to showcase this in action that it's actually working. I don't have the IP address on this laptop. So it's a Kubernetes cluster running on DigitalOcean. And it has my awesome to-dos. Right. Yeah, this will take a while, so I'm gonna stop demoing and open it up for questions. Oh yeah, no, so final thing is some ideas around best practices, which I basically just showcase. Create your containers programmatically. You should be able to create as many pipelines as you want for different purposes, chain them together. We should be able to leverage our services that we've built in our other pipelines, to test our microservices and enforce our contracts. It should be nice if they're version controlled as well. All right. Any questions?
Just put your hand up and I'll bring the mic. Yes.
Can you define your own repositories?
What's that?
Can you define your own Docker file repositories? Because you push to Quay, maybe you want to do it internally.
Yes, so obviously Docker files is something that we do not support. You can specify any Docker image from any hub So Quay, Docker Hub, your private registry, wherever it is hosted. Yeah, so you can definitely leverage containers, but we don't support the idea of building these Docker files because that opens up challenges.
As I know, there are already some CD tools like Spinnaker from Netflix and Fabric 8 from Red Hat. Why you create another one? So is there any difference?
Well, I think, first of all, we were first. So why did they create another one? I think competition is good. I think more people thinking about these challenges is also a good thing. So we can come up with some best practices, especially in this world where it's a fast moving landscape. I think we need more people actually looking at these challenges and looking at these problems. So that's why.
Can I have multiple Kubernetes deployments in one pipeline? For example, deploying it with labels for a dev cluster, a dev kind of environment, then running some tests against it, and if these are green, like deploy it with, like replace the production replication controller?
Yeah, yes, you can definitely have multiple deploy pipelines, either in parallel or sequential, if that's your thing. I think in the case if you want to test your cluster, you should be sort of waiting for something to get spun up, get a result from your test, and then maybe continue. So that would involve something like webhooks, and that's still something that we're working on internally. If that makes sense. Does that answer your question?
Thank you. How do you manage credentials and environment configuration and stuff that shouldn't go into the Docker file or into the artifact?
Right. So we have environment variables that has could have your passwords or your secrets, and you leverage environment variables inside the Docker container as well. So that's sort of how it works. And so you specify them on the service, and then they get pulled in while building or pushing.
But how do they get there? Is this some manual action? Somebody puts them there, puts them into the Kubernetes cluster? Or?
Well, you specify environment variables in your code base, and you can leverage them in your into pipelines. We can talk later about this as well.
Yeah, probably.
All right.
Anyone else with any questions?
Hi. We've used Worker to do deployments on Kubernetes. Something that we found pretty limiting is the 5-minute deploy length, maximum deploy length, because for simplest rolling updates, after 5 minutes, errors starts being ignored. Is it still a limitation for Worker?
No, it's not.
Okay, thank you.
All right.
That's everyone?
Thank you. Come grab a shirt. We got shirts and stickers.
Right. So thanks to Micha.